Hello and welcome to Cambustion. No doubt you are thrilled to receive your new CLD50, which can measure fast NO and NO2. It'll arrive in a shipping box, much like this one, which is very tough and durable, and on the top layer there are various accessories that we'll go through later. And deeper inside there is the analyzer itself, which you should inspect both the box and any of the contents for shipping damage. The equipment consists of the analyzer itself and then a number of different accessories. So you may find a unheated sample line in the box. This is generally used if you are not doing engine work, if you're doing measurement from ambient air perhaps, or some medical applications. The alternative is a heated sample line. This is the 3 meter version of the heated sample line, so that would also be included. There is the communications hardware. So this is a USB to RS245 converter and 10 meters of RS485 cable. And also you may have a filter, and I'll show you how to replace the filter paper in here a little bit later. There are also a selection of tools depending on how you'll be using the equipment. I'll now show you some of the features and the fittings on the analyzer itself. So on the front panel we've got the sample inlet here. This is where you will fit your sample line. There is also, for some applications, a span 0 outlet and a bypass, and there's the electrical connector for the heated sample line. If I turn the analyzer around, on the rear we have a selection of gas inlets for 2 different types of calibration gas if required. 0, that's generally nitrogen, and oxygen inlet. And the reason that that's a different style of connector is so that you can't get them mixed up. Here's our mains power inlet with a switch, and there's a fuse in here as well. This is where our RS485 communications connects. This is a circuit breaker which pops out if the heated sample line has a short circuit. These are 4 analog outputs, 2 each for NO and NO2. And there is a fast and a slow 100 Hz and 10 Hz outlet option. There's a cooling fan, and this is the exhaust from the analyzer. So this will exhaust at a flow rate of about 20 litres per minute, and this should be vented to an extraction system. I'll show you now some of the connections to the rear panel. So here's our exhaust. So that will normally get fitted with some hose to duct that away to an extraction system. These outlets are 0 to 10 volt analog outputs, so you'll scale these with the range that I'll show you on the user interface. I'm using this small portable bottle of oxygen, and something of this size will fuel the LIF, the CLD and LIF system, for about 2 working days. But the connector, which is a shut-off gas connector, plugs in here, and we supply the oxygen at a pressure of 1 to 2 bar gauge. This is where your span gases go in. But our RS485 signal cable, this is what we're controlling the analyzer with, it'll plug in. What I'll show you now is how to fit the sample line to the front of the analyzer, and what generally goes between the sample line and the analyzer is an inline sample filter. So that screws into the front of the analyzer like that, but I'll show you the contents and the filter paper itself. So you gain access by removing the outer clamp, and then if we separate the 2 halves, there is a paper disc filter inside and a support gauze which holds it up away from the sample hole. So the gauze goes in first. There are two sides to the sample filter. There's a woven side and a fluffy side, and it's the fluffy side that goes up, and then the two halves get pushed together and clamp goes back over, and then that can be screwed into the front of the analyzer. And then the heated sample line, that screws into the front of the filter. Now, it's possible to run without the filter, and without the filter you'll get a response time on this instrument, a T10 to 90 response time of about 14 milliseconds. When you add the filter in, you'll have a T10 to 90 response time of about 20 milliseconds. Two pipes are connected. There's one with a red stripe, that's the one that goes to the span 0 fitting, and the unmarked one goes to the bypass, and then the connector, electrical connector, goes on here and can be released with that tab. If you decide to run without a filter, and if you get some contamination in the analyzer, the capillary is accessible through the cleaning ports. There's one vertically for the LIF, and there's one horizontally in the side of the analyzer for the CLD. But you can clean through those capillaries using a cleaning wire that's provided in the toolkit, and you push that down through the capillary and clean it out like that. But if you're subject to that level of contamination, it's better just to run with the filter in situ anyway. So we've got the equipment connected up now. Now it's time to switch on and start warming the analyzer up. So the first thing I'm going to do is switch on the power on the rear panel, and you'll hear a cooling fan which will start, but you'll also see the LEDs on the front panel here which are indicating which gases are connected. So we've got our oxygen connected. I haven't connected any of the calibration gases, so they are indicated as red. And once the instrument starts to warm up and ozone is produced for the chemiluminescence detector, then the ozone light will illuminate also. The user interface, you'll find that on the desktop with this kind of icon for the CLD50. So if I start the user interface, we need to first of all establish the correct communications port. So if I take the advanced setting, in here there is comms setting, COM port here is set to number 3, and that matches the COM port which we'll find under settings. So if we look at our devices, we should be able to see our COM port for the RS232, which has been plugged in to one of our USB ports. If we look at the properties, that should match port 3, COM port 3. So if your laptop, or if you're providing your own laptop and it ascribes it a different COM port number, you'll have to enter that into this box. And also you'll have to have installed the drivers for this USB to 485 converter, which will be sent along with the comms hardware. But we have communications here now, and very broadly at the top we have an output. We haven't switched on yet, but we have our output, which is NO, and we can choose our parts per billion or parts per million ranges. Here is the output for the NO2. Here is our on-off button. So I'm now going to just switch on so that things start warming up. You can hear that pumps have started, and this will take approximately 30 minutes to warm up and reach a point where it can be calibrated. Along the way though, I can show you, if we click on this button that says more info, if we open that up, you can see all of the parameters inside the analyzer which are being controlled. Those which are in yellow are the things which are as yet out of range. So we're waiting for these to stabilize. The instrument can also be configured in 4 different ways. you can take it as only a chemiluminescence analyzer, in which case you'll only get NO, or you can also add to it the LIF, which will give you simultaneous NO2. And then it can also be configured either for engine work, where you would have a heated sample line, or for ambient or medical work, where the sample line, as it is here, is unheated. So you can see that the probe temperature here is greyed out because we have chosen an unheated probe tank. While this is warming up, I'll show you some of the features in the software. So for example, at the top of our More Info page, we've got the gain and the offset for the CLD and the LIF. So you can see here that we've got a positive offset of about 5 ppm on the NO2. So if I adjust this down, the offset, that will come down and take that offset away. If I manually calibrated the system by putting calibration gas from a bottle over the tip of this unheated sample probe, I could change the output level by altering the head gain. So a larger number there will amplify the raw signal to a greater degree. And so if I put in 10 ppm span gas, I would basically adjust that head gain to give me 10 ppm output here, and giving it 0 gas, I would adjust this to 0. These things are moving around at the moment because things are still warming up. When the equipment is stable and all of these parameters are in control, this calibrate button becomes available. If you want to use the auto calibrate one button function, this requires the cal gases to be connected to the rear panel, and our LEDs here would indicate which gases have been switched on and pressurized. Then you would have to enter the calibration gas values into the software, and these are shown down here. So at the moment we're looking at span A of 1000 ppm and span B is 50 ppm NO, and here are the corresponding values for NO2. When we move from, or if we move from an unheated to a heated sample probe, there is a selection of the two there. If you want to log data simply from the user interface, there is a logger which operates at about 10 Hz, and if you press that button, it will log data to a file with a timestamp. It's just a CSV file, but a timestamp alongside the NO and the NO2 concentrations. Furthermore, you can log all of the parameters in the analyzer by pressing this black box button, which is under the Advanced tab. So you can change the frequency of logging, but this is very useful for troubleshooting, for example. So if something goes wrong with your analyzer, we may ask you to log a black box file, and that can be found in the C drive underneath the user interface folder. I'll now show you the set points, because if you double click anywhere within the head info window, you'll pull up a number of set points. So there's a lot in here that you probably won't need to adjust, but we may, with some technical support, ask you to adjust some of these. There are a number of parameters in here grouped together in blue, applying to the NO CLD, in red for the NO2 LIF, and in green, common to both. The analog output ranges are shown here. So we're currently on a 0 to 5000 ppm output for the NO, which means that the analog outputs on the rear panel, when they're 10 volts, this is equivalent to 5000 parts per million. But there are other ranges available, and if you're measuring in atmospheric conditions, you may want to measure in the parts per billion range, and to do that you open up the Advanced tab, and in the bottom here the measurement units can be changed from ppm to ppb, which will require some recalibration, but you can see that the outputs here are shown as parts per billion, with the ppm outputs grayed out. The other thing I should show you are the warnings. So if I propagate a fault by disconnecting the oxygen inlet, for example, the analyzer, once it's depressurized, will show that there has been a fault. So the ozone concentration is not correct because there's no oxygen connected. This auto pops up so that you can see that there is a fault, and then by opening the head info window we can help diagnose what the cause of the fault is. So it may be that the hardware you receive has evolved and looks different to this, same goes for the software, but if you have any questions, contact us using the details at cambustion.com and we will help.